Today I'm here to share with you the fascinating and sometimes unpredictable behavior of our very own star, the Sun. Let's dive into this cosmic journey together. One of the most intriguing things about the Sun is its magnetic field. Unlike Earth's magnetic field, which stays pretty consistent, the Sun's magnetic field flips every 11 years. Imagine a giant cosmic switch that turns the magnetic north into south and vice versa. This flip-flopping leads to periods of high and low solar activity, known as solar maximum and solar minimum. Right now, we're on our way to the next solar maximum, expected to peak in 2025. This means the Sun is becoming more active, and we can expect more solar flares and sunspots. But what does all this mean? Let's break it down. The Sun is the closest star to Earth, making it the only star we can study in such detail. We can actually see the Sun's surface and observe how its gas and plasma move. These movements create convection currents where hot material rises, cools down, and then sinks back. This churning motion is fascinating to watch and crucial to understanding the Sun's behavior. Like Earth, the Sun has a magnetic field with a north and south pole. But here's where it gets interesting. The Sun is made of gas and rotates differently at its equator and poles. The equator spins faster than the poles, causing the magnetic field to twist and tangle over time. This twisting creates loops and knots in the magnetic field that can store immense amounts of energy. When these magnetic loops snap, they release solar flares and coronal mass ejections, CMEs. These powerful bursts of energy and particles shoot out into space. If a CME heads toward Earth, it can collide with our planet's magnetic field, leading to stunning auroras, but also posing risks to satellites and power grids. During a solar minimum, the Sun's magnetic field is calm and orderly, leading to fewer sunspots and flares. But during a solar maximum, the field becomes highly distorted and we see a lot more activity. This cycle of flipping magnetic poles and varying solar activity repeats every 11 years. Now let's take a step back in time to the mid-19th century and the famous Carrington event. In September 1859, a massive solar flare caused geomagnetic storms that disrupted telegraph systems across the world. The auroras from this event were so bright that they were seen as far south as the Caribbean. Fast forward to 2012, when a colossal solar flare narrowly missed Earth. Had it hit, it could have caused widespread disruptions to our modern electrical infrastructure. To keep us safe, astronomers continuously monitor the Sun. Organizations like NASA Astronomy and Space Science Institute provide real-time data on solar activity. This helps us predict solar storms and minimize their impact on Earth. It's like having a weather forecast for space, but the Sun's influence doesn't stop with Earth. Let's talk about Mars for a moment. Mars, our intriguing red neighbor, may have once had a magnetic field similar to Earth's. However, over time, Mars lost its magnetic field, which led to the loss of its atmosphere and water. This transformation turned Mars into the barren planet we see today. Understanding this helps us appreciate just how crucial Earth's magnetic field is in protecting our atmosphere and supporting life. Exploring Mars is one of the most exciting frontiers for scientists. However, Mars's weak magnetic field means it offers little protection from the Sun's harsh solar radiation. This makes long-term habitation a significant challenge. Scientists are working hard to figure out how to protect future explorers from these risks. In conclusion, the Sun's behavior, with its magnetic flips and cycles of activity, is a source of endless fascination. It affects not just our understanding of stars, but also our technology and safety here on Earth. As we continue to explore space, keeping an eye on the Sun and understanding its influence is more important than ever.